To determine the initial number of infected patients, or what the function equals when t equals 0, we need to plug in 0 for t in our equation. So we're looking for p of 0, which means we're going to have 400 over 1 plus e to the 5th minus 0, or simply 400 over 1 plus e to the 5th, which is approximately 2.67. And since we're talking about infected patients, we're going to round that up to 3. And that will be the answer to part A. Now for part B, it's a very similar procedure. We're looking for the number of patients infected after 2 days. So now we want t to equal 2. We're going to figure out the value of p of 2. So that's going to be the same thing as 400 over 1 plus e to the 3rd, and that's going to be approximately 18.97, or rounded up 19 infected patients. And that will be the answer to part B. Now for part C, we're given the value we want the function to equal. We know we want there to be 200 patients that are infected, and we're trying to figure out the time. So in this case, we're going to have 200 equals 400 over 1 plus e to the 5th minus t. We can start by cross-multiplying, and that's going to give us 200 times 1 plus e to the 5th minus t is equal to 400, and then we can divide both sides of the equation by 200. This is going to leave us with 1 plus e raised to the 5 minus t equals 2. We can subtract 1 from both sides of the equation, which will leave us with e raised to the 5 minus t power, and that will equal 1. From there, we can take the natural log of both sides of the equation, which will allow us to get the t out as an exponent. So we'll have the natural log of e raised to the 5 minus t equals the natural log of 1. That allows us to take that exponent and bring it out in front of the log. So we'll have 5 minus t times the natural log of e is equal to the natural log of 1. Now we have a couple natural log definitions here, but the natural log of e is just going to equal 1, and the natural log of 1 equals 0. So what we're left with is 5 minus t is equal to 0, and if we add t to both sides of the equation, we will end up with our answer to part C, which is 5 is equal to t, or t is equal to 5 days. Again, that'll be our answer to part C. Now for part D, this is just a matter of knowing your logistic equations. The carrying capacity, or the maximum number in a logistic equation, is always the numerator. So that maximum capacity, in our case, is 400. So the maximum number of patients that could be infected, according to this model, is 400. And that will be the answer to part D. And all of that together is our final set of answers.